The back problems are very similar, they just have a number outside. So this is how you're going to solve it. To break down 150, we would use 15 and 10, and then we have 3 and 5, and 5 and 2. So we have a pair of 5s with 3 left over and a 2 left over. We also have an R that would be boxed. So outside we already have that -6. We're just going to multiply the pair of 5s to it. And then inside we have the 3 left over, the 2 left over, and the R left over. Our final answer here would be -30 square root 6R. 23 is very similar. To break down 192, we would have 2 and 96. To break down 96, we would have 2 and 48. And then we have 6 and 8, which would break down to give us 2 and 3, and 2 and 4, which breaks down to give us 2 and 2. So I have one pair of 2's, I have another pair of 2's, and I actually have a third pair of 2's. The 3 is left over. For the x, we're just going to box it because there's only one of them. So the -4 is already there, but then we're multiplying one pair of 2's, two pair of 2's, three pair of 2's, and then left over on the inside we have a 3 and we have an x. So this simplifies. -4 times 2 times 2 times 2 is -32 square root 3x. Finally, number 27, 16 is a perfect square. We know that 4 times 4 is 16. We have 4 x's, which is 2 pairs of x's. We have 4 y's, which is 2 pairs of y's. And we have a z, which is going to be boxed. So on the outside, I have a 3 times my pair of 4's. I have an x for my first pair, an x for my second pair, a y for my first pair of y's, a y for my second pair of y's, and underneath all we have left is z. So my final answer here is 12x squared y squared square root z.